Section 5.4, Day 1, Completing the Square. The essential question: how can I solve quadratic equations by using square roots and completing the square? Many quadratic equations contain expressions that cannot be easily factored. For equations containing these types of expressions, you can use square roots to find roots. So this is just another method that we're going to use to find roots. Zeros and x-intercepts. So right here, you would subtract 11, because what we're trying to do is get the x squared all by itself. Divide by 4. And take a square root. So now we won't leave our answer as plus or minus root 12 because we know we could break root 12 into the square root of 4 times the square root of 3, which is 2 root 3. And because we took the square root of a x squared, we needed a plus or minus, which makes sense because we're going to get 2 roots because we're dealing with a parabola. So this is an example of using the square root method because it could not be factored. The next one we're going to do in class. If a quadratic expression of the form ax squared plus bx cannot model a square, you can add a term to form a perfect square trinomial. This is called completing the square. Again, this is another method used to find the zeros, the roots, the x-intercepts. So it's saying to complete the square of x squared plus bx, we're adding b over 2 squared. So that's what we're going to practice doing right now, because what we're trying to create is a perfect square trinomial. So on example 2, if we look, we know b is equal to negative 14. We know that b over 2 is going to be negative 14 over 2, which is negative 7. And if we want to deal with b over 2 squared, we're going to square that, and that's going to be 49. So that's what's being added there. By doing that, you're creating a perfect square trinomial. Same thing down here. B is equal to 4. B divided by 2 is going to be 4 over 2, which is 2. And b over 2 squared is going to be 2 squared, which is 4. And that's what's going there. So all we're practicing here is to create a perfect square trinomial that we can use when we are using completing the square. We haven't gone through a whole example of completing the square yet. We're just practicing adding the b over 2 squared. Example 3, we're going to do in class. Looks like example 4, we're going to do in class. No, we're not. Example 4, we're going to do right now. Solving quadratic equations by completing the square. So here are the steps that we're going to follow that I'm going to talk through as we go and solve this. So number one step is we're going to collect the variable terms on one side of the equation and the constants on the other. So this is different than factoring. Remember, on factoring, we would have moved the 12x and the 20 over to the left side and set everything equal to 0. Here, we're going to move all the variables over to one side. So that's going to give us x squared minus 12x, and I'm leaving a plus and a space, and negative 20 on the other side. Now, what we're going to do is we're going to create a perfect square trinomial by adding b over 2 squared to the left side. And if I add it to the left side, I also have to add it to the right side. So I know b is negative 12. B over 2 is going to be negative 6. So b over 2 squared is going to be negative 6 squared, which is 36. As long as I add something to the left side and I also add it to the right side, I'm okay. What happened here is by doing that, we've now created something that we can factor. And what you're going to find on completing the square is you're going to create a binomial. When you factor it, it's going to be a binomial squared. So factoring it, the two binomials are going to be exactly the same. So now we have an x minus 6 squared. So I have to take the square root of the left side and of the right side. When I take a square root of the squared, this 2 is going to cancel. This comes out, and we get plus or minus 4. Again, whenever you take the square root of a square, you get a plus or minus on the opposite side. Add 6 to both sides because we're solving for x. So x is equal to 6 plus or minus 4. Well, that results in two answers. 6 plus 4, which is 10, and x equals 6 minus 4, which is 2. So we have just found, and you can write them like this also, we have just found the roots, which are the zeros, which are also called the x-intercepts. And the method we used was completing the square. And it's a method that we use typically when a trinomial is not factorable or a quadratic equation is not factorable. Example 5, save for class. Example 6, save for class. And video questions. Solve the equation by using square roots, and then solve the equation by completing the square.